In this video, we're going to continue talking about cross product, not as much what it does, but more how to actually calculate it. So again, just a quick rehash, the cross product of two vectors creates a new vector that is orthogonal, so it meets 90 degrees to both of the original vectors. So we say the resultant vector is orthogonal to the original two vectors. Again, there's a proof for this. I mean, it really is created to do that. You know, we create this to say we're finding a vector that when I dot with this and with this, each dot product yields 0. All right? So here's how I organize this. I do this with a matrix. I begin by saying, okay, I could write this as ijk, right? X, Y, and Z. I've got a x of 2, a y of -4, and a z of 6. And the other vector looks like this. Okay? You'll see, and I hope that the calculation makes sense as what we described cross product, in that you can look at the formula up here, but I think I can even make it easier by saying we are going to look at how I is being affected, or the x, by the y and z's. We're going to look at how y is being affected by the x's and the z's. And we're looking at how z is being affected by the x's and the y's. Remember, dot product keeps everything together. It says x's with x's, y with y's, z's with z's. Cross says, how is x being affected by these other forces? So, the formula says you have a matrix with I minus a matrix with J plus a matrix with K. And we need these new matrices. They're pretty easy to find. You say, if I'm looking for I make a new matrix out of the J and K square. So this becomes -4 and 6 and 5 and 3. Okay. If I'm looking for the J matrix, how y is being affected, I go to x and I go to y. So, I mean, it's up to you how you want to write this. I could say, well, it's 2 and -1. Those are the x's. And 6 and 3 are the y's. And finally, the z, I've got this square matrix left over. So I've got 2, -4, and -1, and 5. Big thing to be careful of and notice is that in the formula, the I matrix is kept positive, the K matrix is kept positive, the J matrix is opposite. And that really comes from the proof. Why that works out the way it does, it comes from this proof of we need them to dot to 0. It really is just the formula you kind of have to know. Now, for each of these, we simply find what's called determinant. A determinant says you kind of multiply across, and then you subtract the other one. So -4 times 3 is -12. 6 times 5 is 30, so we write down -12 minus 30, and this is my I. Okay, so let's go here. We've got 6 minus -6. So 6 minus -6, J. And 10 minus 4. And that's K. So let's simplify. We have -12 minus 30. That's -42. I'm going to put this right here. 6 minus -6 is 12. But remember, the K has a negative in front, so it's going to be -12. And 10 minus 4 is 6. So this is the resultant vector. This is the cross product. If you dotted this blue vector with this first one, you would get 0. If you dotted it with this one, you would get 0. We have created a vector that is orthogonal to the original two. Okay, let's do it again. And maybe we'll be able to simplify our work just a little bit. Okay, so let me write this matrix, IJK. So we've got 5, 2, and negative 2, and 3, negative 1, 2. All right, so let's calculate this without maybe having to draw these new vectors. I've got 2 times 2, 4 minus 2. So let me write this down. And that's I. J is always a little tricky to see because you got to kind of skip over that and ignore it. 10 minus negative 6. Let me write that down. And for K, we're going to say negative 5 minus 6. All right, so my resultant vector is 2 in the I direction, 16 in the Y direction, and negative 11 in the Z direction. And again, if you dotted this blue vector with each of these original 2, you would get 0. The last thing I want to talk about in this video is what's called the right-hand rule. The right-hand rule is really helpful in knowing the direction of a resultant vector or force. So in this, and this is going to be a little bit tricky to do in the video, so I would urge you to kind of work along with this and actually use your hand to figure this out. The right-hand rule, obviously we use our right hand, and we're going to work with the A cross B. Okay, so the first vector, we use our pointer finger and we point in the direction of the first vector. So in this case, you'll point in this direction, okay, with your pointer finger. Then you will turn your hand so that your ring or your middle finger points along B. So turn your hand however you need to so that you are pointing along B. So your right hand pointer finger should be pointing in the direction of A, with your middle finger pointing the direction of B. So the question is now, is the resultant vector going in or out of the page? Your thumb tells you the direction. So if you are pointing in A with your pointer and pointing in B with your middle finger, your thumb should be pointing into the page. Okay? Check that. Make sure you have that correct. Next, if our pointer is pointing in the direction of A and our ring or our middle finger is pointing in the direction of B, so make sure you do that, your thumb will point in the direction of the resultant vector. This will be coming out of the screen towards you.